Hello, welcome to VoltScript Ventures. My name is Devin Olson, and today I'd like to tell you about VSS Libraries Part 03, the VoltScript Testing Library. Now, the VoltScript Testing Library, we have some specific goals that we aimed to meet. First off, the purpose of this is to provide unit testing tools, standardized unit testing tools that are easy to use and make easy, clear, readable tests. We want it to be easy. That's really, really important to us. We want to be able to provide the ability to generate documentation. We want to be able to integrate with continuous integration and continuous delivery processes and have those available to developers. We want to provide most of the commonly used assertions and not overwhelm you. And we want it to be flexible, and I think most importantly, and this is from me, we want to provide a pleasurable coding experience. One of the things that we end our meetings with when we have development team meetings here is we wish everybody to have a happy coding day. And that's really important because we genuinely believe that joyful coding is good coding. Now, the VoltScript Testing Library is available. It's open source and it's available for you at github.com, HCL Tech Software, VoltScript Testing. And this is what it looks like here, up right here. This is the VoltScript Testing Framework. It provides this testing and these things that I've started to speak about and I'm going to tell you about. But I do want to take a moment and I want to call out Paul Withers. Paul Withers was the lead architect and contributor to this. He doesn't know I'm saying this about him. This guy is a really hardworking fellow, provided excellent direction and a lot of hard work, sweat and tears of his own went into putting together VoltScript testing. So massive kudos to my friend Paul. All right, let's continue on. Like I said, VoltScript testing is designed specifically for unit testing. And I want to call out a blog post. Let's go back 20 years to a blog post from April of 2005. Jeff Atwood posted this. You may know him as the guy who invented Stack Exchange. Jeff Atwood is a really, really good developer and a very good writer. I loved reading his stuff years ago. I still do. And he posted this, he asked some very good questions. What makes a good tests? And couple of things he points out that I want to remind people of is most developers don't test at all. Still to this day, most developers don't do unit testing or their own development testing. And unit testing forces you to stop and think about unit testing. And that's really important. You need to think about your tests. And then he's got another post called I Pity the Fool Who Doesn't Write Unit Tests. And in this post, he talks about a number of things. Unit tests provide your code works. You get low-level regression suites. You can improve your code, etc. But then these two bolded points are really, really important. Unit tests are so important that they should be a first-class language construct. That's the reason we built this library, so you, the developer, can use unit testing and implement unit testing in your environment. The next point, asking developers to fundamentally change the way they approach writing software overnight is asking a lot. And yes, we realize this is asking a lot because we also realize that most of the developers who are going to be starting to use VoltScript come from a LotusScript background. And in the LotusScript world, the sad real truth is almost nobody does unit testing. Just simply, that's just how it is. That's how the world is. Very, very few people do unit testing. They say they do a little testing, but they don't do unit testing. And at this point, any tests are better than zero tests. We're hoping that people will listen to the drum we're beating and start following this path and start implementing unit testing in their code. Why is it important? Well, unit testing and a unit testing library allows you to have consistent tests. It allows you to repeat them over and over and over again, meaning every time you do a commit, every time you update a library or update a class or make changes, you can repeat and rerun your tests basically to make sure you haven't broken anything. You can also implement them. They give you standard reporting, and most importantly, this library is very, very, very easy to implement. It's really important. These were a lot of things that we really, really wanted people to get into. So let's dive into VoltScript testing and my demonstration. So here we have a very, very clean, simple, and empty, with the exception of my atlas.json, an empty Visual Studio Code development environment. For those of you who have not yet watched Rocky's video on VoltScript and dependency management, please, you need to do that. You need to understand how we do dependency management. So for this VoltScript testing demo, my atlas.json is identifying I'm doing a VoltScript testing demo, and I'm going to pull the repository directly from github.com, this repo that I showed you just a moment ago. I'm going to pull this live, and I'm doing my VoltScript testing. So let me go ahead and get this going. I'm going to install my dependencies, and I'm just going to take all the defaults, go, bang. My libs folder has been created, my source, my test, my VSS folder, all of this has been created for me, and there's my VoltScript testing. Let's get going. All right, I want to start by closing my atlas.json, closing this, and let's get very, very simple. We're going to get started. I'm going to go to my test folder, and I'm going to create a new file, and I'm just going to call this basic tester. There we go, basic tester, and within this file, this is going to be where we're going to start creating our tests. And let's see, this is going to be a basic testing demo, and we're going to option explicit, option public, and I want to use libs VoltScript testing. Here we go. Let me start by creating a sub initialize, and in this sub I want to create a test runner. I'm dimming a runner as a test runner, and I'm setting my runner equal to a new test runner. I'm giving it a name, and I'm setting an output format. Oh my gosh, what are you doing, Devin? You've confused us. Yes, I know. That's okay. Just bear with me a moment. So what the heck is a test runner? Well, let's come back over here to our VoltScript testing, and in our VoltScript testing, if you click on this link, it'll get you some documentation, and from there you can get to the API documentation for VoltScript testing, and we can learn about our classes here. We have a type. There's the main library, VoltScript testing. We have a type and these classes, and let's take a look at the test runner class. What's the point of it? Well, it's a wrapper for generating multiple tests. It produces our HTML content. It produces our output. So the test runner is our master tester class, and that class we will add test suites. We'll add test suites, and what is a test suite? Well, right here is a test suite. We'll add test suites to the test runner, and we'll use these test suites to test the stuff that we need. All of these things are inside of our library, so that's kind of how we're going to do it, and it's easier and I think faster for you to understand all of these things and how they work by simply diving right in. So that's the entire point of this. So we're going to start, like I said, by creating this test runner, and we're going to give it a name and set an output format. Well, what does that mean? Well, just jump back here real quick. It's not really that hard. Set output format right here in the documentation. Basically, the test runner, when it generates this output, it can generate XML, or it can generate HTML format type. So we can say HTML or XML, or we can say both. And if we say both, it will produce HTML and XML output. Well, what does that mean? Well, we're just going to create some output files, and then we can use those files to read the results of our tests. So just very basic. Let's kind of get going. Why do we need both HTML and XML? Well, humans read HTML and systems read XML. So if we produce both, we can produce reports that humans can read, and we can produce content, that XML content, that automated systems can read. Why do we want to do that? Remember when I spoke about continuous integration, continuous delivery? That's exactly why. Here at HCL, when we're working on our VoltScript code and we're producing things and we do our testing, we could manually, personally run a unit test, and I tend to like to do that so I can actually see the reports. But in addition to that, what happens is when we check in code, we go into GitHub and we do a commit and we do a push and we push it up. Before that code can be merged, another human has to look at it and review the code. But in addition to that, our automated CI/CD system runs those unit tests for us in an automated process and confirms whether or not that code works or whether or not that code fails the test. And this allows us to never build code with a unit test failure in it. Yes, code can still be released with bugs. That really does happen in the real world, and that can happen, but those are more design flaws, design bugs, rather than unit tests. And also, this type of testing allows us to avoid regression failures. So say you're working on a library or a class or something, and you have things that work, and then you go in and you make an enhancement and you modify one part, something else, and suddenly those things that worked before, you've now broken something. Unit tests allow you to identify before a merge if you've broken something. So that's the entire reason for that type of testing. It's critically important. Let me start by creating a global property for this library. So right here, I'm going to just paste this code in, and I'll talk about what it's going to do here in a moment. So I have a property get, and it's called it's a fail test with error property, and it's going to return a Boolean, and so return a true. But that would work, except for this line 11. It's going at line 11. It's going to throw an error called "This is a test error message." So far, so good. It's a simple error. Basically, if I were to call this property, any code that calls this property will error out, will generate a hard, solid error. Why is that there? Well, it's not part of the test suite. It's just part of my tester, and I'll explain that in a minute. The next thing I'm going to do is I'm going to go ahead, I'm going to create a sub that will generate a test suite and test it. So let's start this. All right, so here we have this sub called test booleans and strings. You notice I pass in a runner, a test runner. There's my runner. I'm going to pass that in. Could I make this a global? Yes. Do I want to make that a global? No. Why? Because I generally hate globals. So just there we go. Inside of this method, inside this sub, I'm going to create a test suite as a new test suite. So I'm creating a new test suite. I'm giving it a name. I'm dimming a Boolean variable. I'm just calling it A for the time being. And then I will add the test suite, this new one that I've added, to the runner. So runner add test suite, and then I will do my actual testing. So I say test suite.describe, and I want to test basic fail Boolean true, and I'm going to call its assert true method and pass in A. A is a Boolean. It hasn't been instantiated yet, so that is a false. So this test should show a failure. Then I want to describe it, and I want to assert false, and I call the assert false method, passing in the same thing, and it should pass because it's false. I'm going to flip it to true, do the same two tests. Now I want to describe that I'm going to try and do a test error, and then I want to call test suite, and I want to assert true, and you'll notice I'm passing that property in. So I want to pass in this property, so because this property returns a Boolean and I'm asserting a true, that assert true test should work. But if you stop and remember, it's going to throw an exception. So there we go. So I have this in a try-catch block. If we catch it and if it throws an error and we catch the error, we will add the error information to the test suite, including the error message, and get thread info 12, which is a wonderful new cool tool in VoltScript language. This doesn't work in LotusScript. Sorry, LotusScript people, but in VoltScript, get thread info 12 will give us an entire stack. Then I'm going to continue on and do these other things. I'm going to do some additional testing. I'm going to assert that this is a string. I'm going to assert that these are equal, and I'm going to continue the tests. And I could add a bunch more, but for right now, we're just going to start with that. So let's come back up here to our initialize method. And all I want to do is here, and I just want to say call test booleans and strings and pass it the runner. And that's all I'm going to do. And let me run this code now. And look carefully, look over here. There's my library, my VoltScript testing, source test, VSS. There's nothing else over here yet, right? Well, let's run this. Command Shift P, save and run the script, go, boom. The testing ran basic tester, Boolean and string tests. I did 9 tests. I found 1 error. I had 4 failures and 0 missing assertions. Unit test reports, this new folder was created with a basic tester, hence the name, that long string, which if you look carefully, there's a timestamp. I know when that was created. I have an XML file. This is the file that would be read by a machine. I have some HTML. I have my index. So let's go ahead and take a look at this actual stuff in a way that we can read it. So let's just come down here and open up my Finder to this projects and VoltScript testing demo. There it is. I lost my unit test report folder. Unit test reports, there's that subfolder. There's the XML, the HTML, and the index. Let me open this index file and we'll see what happened. Boolean and string tests failed. Well, why did it fail? Well, let's take a look at this. Test fail basic. This is notifying me that this test failed. Okay, expected false but was true. This test succeeded. Nice green check mark. We're using the blue, green, red standard, meaning green is good. Blue means something was caught correctly and did not pass what was expected but didn't break. And red means an error occurred. What's the error? Error, this is a test error message. Error number 1000 on line 51. The stack, basic tester, test booleans and strings. Line number 53, basic tester sub-initialize. There's an entire stack. So if we could take a look at this error message on line 51. Let's come back to our source code. Basic error tester, line 51. That's where the error occurred. Well, wait a minute. The error actually occurred way up here on line 11. Of course it occurred on line 11, but the try-catch was at line 51, and that's just how try-catch blocks works. If you don't have a try-catch block someplace else, closer to where the error occurred, you can't tell exactly, but that gets us close enough. So very, very basic, very, very simple testing. We're going to add some more stuff here in a minute, but that's just enough to get us started. Okay, let's move on, and let me show you a few more tests. I'm going to expand upon this logic a little bit. I'm going to add another method here, and I'm going to call this, I'm copying this in from some other code that I have elsewhere. I'm going to call this test variance, and basically what we're going to do in this test is just like in the first method, we're going to get a runner that's going to come in. We're going to create a new test suite. This is called complex variance tests, and we've got 2 variables in here that we're going to play with, A and B, and they're both variance. And so we add the test suite to the runner, and then we start setting some values, and then we start doing some testing. And again, and the way this code works, so we take the test suite and then we describe the test with the describe method, and then we chain it, and now we perform the test. So we're going to assert equals a primitive, A and B. So we're going to assert that A equals B and that they're primitive tests. And we're going to describe it again, do the next test, describe it again, and between these, and let me break this up just a little bit so we can see what we're doing. And between these, we're going to change the value of A. So we start with 1.0, then a 1, then a negative 1.0, and negative 1. And then down here, we set A back to negative 1.0. We set B to the text of true as opposed to the Boolean of true. And we continue to do some more tests. We test B, set B to the test of foo, and then we do some more tests. We test for double and a string and passing in A. So not really that complicated, but let's go ahead and take a look at how this one. Go ahead and run this test, and it is created. We created our new tests. We tested 9 things. Oh, no, dummy. Come on, Devin. I need to call this method. So call test variance and pass in the runner. All right, now let's run this again. Okay, there we go. So now we've got, we did the complex variance test, we did Boolean and string tests, so we've got 12 tests. This time we had no errors on the second test, and then 5 failures. So let's go take a look at those results real quick. There's the Boolean and string test. Let's go ahead and close that browser and come back to here. And that's the second test, and here's the test that we just did. Open up that index, and so now we see there's, just as before, the Boolean and string failed exactly in the same manner that it failed before, but here's this new complex variance test. So in the results, every time we add a test suite, and the test suite has a name, that test suite will show up in the results here. So boom, boom, boom. So here on this complex variance tests, we run through the test. We didn't get any errors, nothing blew up, okay, but we did get some failures, which were failures, and then a bunch of things passed. And so, like, just as an example, does 1 equal true, expected 1, but it was negative 1, so that failed. And then this test of true, type mismatch between negative 1 and actual value, the text of true, foo, those kind of things. The thing I wanted to point out here, and this goes back to my other video on collections when I talked about you can't put a variant into a collection as a content type, and this is why. So here we're testing, is A a double, and then we're testing, is A a string. So test it passed as a double. If we come back and look at our code, we close this. Test A is a double is right here. We're testing to see if it's a double. Well, at this point, A is equal to negative 1.0. Is it a double? Yes, it is. But if I do, and then is it a string? Well, no, it isn't, and that's why it failed there. But if I do just this much, and I come to right to here, and I say, you know what, I'm going to say A equals A, and just like that, and we run this again, okay, everything worked, but let's come back out of here, close this test, look at that next result, and now we failed because A is actually an integer, and that's the thing I wanted to talk about. So even though A was declared as a variant, at runtime we can't tell if something is a variant. We can only tell it what it is at runtime. Show that again. Boom, boom. And close that. Back up, grab the next test. There we go. Fails again on the double, but now it passes because it's a string. So it's just a little thing that I wanted to show real quick. There's quite a few other interesting things we can do with testing expansion and stuff like that, but I'm kind of running out of time on this demo video. So let's go on and talk about some challenges, okay? And these are the challenges that we faced when we were putting together this testing library. First off, there's no anonymous or abstract functions or lambda type expressions within VoltScript. VoltScript and LotusScript, they don't even understand the concept of an anonymous function. Okay, so code can't be passed to a before all function and to do their tests. So how do we get around that? Well, we get around that this class here, the abstract custom before after. So this abstract tester that you can build, this abstract class, you can extend this class and then use that in your testing so that you can do a before all or a before each or an after all or an after each. So we have the ability for you to do that, but you have to create your own testing code and you have to extend this. And the same with the abstract custom tender, the same kind of thing. So that's what you have to do with that. And that comes down to the next point. Core language functions cannot be extended. VoltScript language and its predecessor LotusScript cannot, you just simply cannot extend core functions like you can with some of the more modern languages. Just a fact. In VoltScript VSE classes, just like in LotusScript with LSX extension classes, they cannot be extended because of the design and the architecture of the language. But VSS classes can. So VSS classes can be extended, and that's what gives you the ability to extend these classes into your own. So there's ways that we manage to make this work and make it work well for you. So for mocking code and stuff like that, we've got to do this type of extension. Basically, you got to run your tests and extend your code. There's a lot more information in the documentation. Go play with it. The last thing is, for those of you who do Java development and have kind of stepped into that realm and enjoy it and love annotations, which really make Java wonderful, the concept of annotations simply does not exist in VoltScript. There is no concept. There's no way to identify unit integration testing functions in a way that VoltScript can automatically identify. And so the way you do that is you add your tests at the end of the VoltScript library module, and that's kind of how you get through that. One more thing I wanted to show you so that maybe I can help explain a little bit of this quickly, some existing code. So you recall I spoke earlier about us using this testing library to test our real code. And so demo time, VoltScript testing, it's really not, but we'll come back over here and I want to show you this library. This is VoltScript collections. This is the actual library. This is the real code. You can go up to GitHub and pull this code down and take a look at it. But I want to come down to our testing area, and this is where our real tests are run. This is where we really test our code. So if we come in here and we're going to update something in this library, we're going to make some changes, some enhancements, whatever, okay, and we're going to modify our VoltScript collections. Before we send that out, we have to run our tests, and we come over here and we run our run all tests, and we use our collection unit tests and our map unit tests. So that gives us two separate sets of tests, one specific for collections, one specific for maps, and we can run the tests. So if I take a look at the collection unit tests library, we have a special comparator that we use to extend. We have a class person that we use for raw testing. We create another comparator. We're creating all of these extensions of our existing classes. Remember, I spoke about mocking code in order to test our code. Here's the real tests. So we, like for here, perfect example, call test basic collection test runner. Well, that's right here, and in here we pass in our test runner, we create our test suite just as I said before, and we run through and we do all of our tests. And this allows us to test things like input validation, input verification. Are we failing at the appropriate times? And more importantly, are we not failing at inappropriate times? Have we introduced a regression bug whenever we do our test? Or excuse me, whenever we make changes to the library. So this is real time, real code. This is the real stuff that we're actually using to do our testing. So I just wanted you to see that, understand that this is real and it works, and it's not just some pie in the sky project. It really does work. That's back to our challenges, and that's the end of the video. So once again, my name is Devin Olson. Thank you very much for joining us on this VoltScript testing video, and happy coding.